Select the diene and the dienophile that should be used to synthesize the following molecule. So a few things should jump out at us here. Diene and dienophile. And we also see that we have a 6-membered cyclohexene in this. These are all hints for us that the reaction that we're dealing with is the Diels-Alder reaction. And so installing a Diels-Alder product, we saw that we should always start with this general framework. In working backwards from the product to the starting materials, we should also follow this general framework. A Diels-Alder reaction will always involve a conjugated diene and a dienophile. And so in drawing these starting materials, I can start by drawing these frameworks because I know I have to have had a diene. And I have to have had at least one pi bond in the dienophile. And I'm going to number these the same as we have in the model up top. And then I need to find the 6-carbon atom ring in the product. So right away I see this pi bond. That's going to be carbons 2 and 3. And so the bottom ring here is that 6-membered cyclohexene ring. So what I want to do is recognize that these are the new bonds between 4 and 5 and 1 and 6 that formed in the reaction. So I'm going to look at everything else that's attached to the carbon atoms 1 through 4 and 5 and 6. So if I look at 1 through 4, the only substituent I had initially, besides those bonds, is this bridging oxygen. So that means that I have an oxygen that is bridging carbons 1 and 4 for my diene. And then if I look at the dienophile on both carbons 5 and 6, I have cyano groups. These are both pointing down. That tells me that this was a cis alkene. And so I want to make sure in my alkene that they are pointing in the same direction. And so that alkene is sp2 hybridized. Right, so here is showing that sp2 hybridization. So notice I'm not using dashes and wedges. I'm representing that trigonal planar geometry. I know it's cis because they're sitting on the same side, right? If we kind of look through the center, we see they're pointing in the same direction. And so this is option A, right? And so the biggest probably temptation of what to answer, I think, would be C. And so you should look and see what distinguishes the two, and it's the stereochemistry of that alkene.